of demographic data. I stand before you all to welcome the erudite Professor Vandana Dikshit Kaushik Ma'am, an accomplished Dean of Quality and Assurance at Harcourt Butler Technical University, Kanpur. Ma'am brings a wealth of knowledge and experience to our conference, specializing in digital image processing, biometrics, and indexing. Her academic journey includes a BE in Computer Science from Pune University and a PhD in Computer Science from AKTU, Lucknow. Since joining HBTI in February 2003, Ma'am has played a pivotal role in both teaching and research. Ma'am's instructional portfolio spans diverse subjects such as database management systems, operating systems, digital image processing, and e-commerce, contributing significantly to the academic development of her students. Engaging in collaborative efforts with prestigious institutions like HNB Garhwal University, Guindy College of Engineering, IISc Bengaluru, and Indian Institute of Technology, Kanpur, Ma'am has left an indelible mark. Her involvement in the multi-core curriculum development project sponsored by Intel Bengaluru underscores her commitment to shaping the future in computer science education. Ma'am's research areas include 3D image blurring and deblurring, medical imaging, data indexing, 3D face recognition, and biometrics. As a dedicated academician, she serves as a board member on the Board of Studies for CS, IT, and MCA at Dr. APJ Abdul Kalam Technical University, Lucknow, and HBTU, Kanpur. Her active participation in the international conferences and her role as a reviewer for numerous impactful papers demonstrate her commitment to advancing the field. Today, we are privileged to have Ma'am with us share her expertise. Please join us in extending a warm welcome to Dr. Vandana Kaushik Dikshit Ma'am. Ma'am, please.
So good morning again, all of you. I would be sharing this work of mine. This was in collaboration with IIT Kanpur, and it goes back to somewhere around 2014, and the entire work was published in Springer Conference, ICIC. That's a very renowned conference, and I think up to 15th या 16th हो चुकी हैं, and generally China में होती हैं ये सारी conferences. So ICIC, I think 2015 or 16 I presented this work. Why I wanted to share this with you is क्योंकि like this demographic data is very, very vital now for computer. I think all of you are computer science students? Okay. So we all work in the biometric data. Like what is biometric? पता है आप लोग को? How many? What is biometric? Can anybody please tell me this? Any one of you? Yes?
Fingerprint, iris scanner, and other fingerprint that is using Aadhaar and that kind of information are modeling.
What's your name, gentlemen? Pulkit, very good. Biometric is certain trait which you possess. That trait can be your fingerprint, your iris, your DNA pattern. There are soft biometrics, there are hard biometrics. These are the characteristics which a person possesses, जो अपनी आइडेंटिटी बता सकती है. जैसे कि आपके फिंगरप्रिंट पे जो माइन्यूशिया पैटर्न्स होते हैं, जो ये होते हैं ना, ये आपके वर्ल्ड बोलते हैं इसको या रिंग्स बोलते हैं, जो ये पैटर्न होता है, दिस वी से इज यूनिक फॉर ईच एंड एवरी इंडिविजुअल. ठीक है, इवन ट्विन्स में भी ये पैटर्न्स यूनिक होते हैं. तो जैसे कि हम लोग पहले ज़माने में सिग्नेचर से अपने आप को आइडेंटिफाई कराते थे. बैंक में यू गो एंड यू वांट टू विड्रॉ मनी, कैसे करते थे? आप साइन करते थे, साइन मैच करते थे, अगर आपका साइन मैच हो जा रहा है तो वो कहते थे हाँ नाउ यू कैन विड्रॉ द मनी, और यू कैन डिपॉजिट कर सकते हो या विड्रॉ कर सकते हो, या किसी हाई एंड सिक्योरिटी एरिया में आपको एंटर करना है, लाइक फॉर एग्जाम्पल यू वॉन्ट टू एंटर इनटू इसरो लैब या नासा के किसी लैब में एंटर करना है, दैट इज अ हाई एंड सिक्योरिटी एरिया, ओनली द ऑथेंटिकेट पर्सन कैन एंटर. If I am not the person, a scientist from ISRO, I will not be allowed to enter. तो कैसे करते? You either पहले होता था कि साइन करते थे या आईडी होती थी आपके पास, उसको गार्ड मैच करता था, if it matches then you are allowed to enter. ठीक है? यहाँ पे फॉर्जरी के बहुत सारे चांसेस, यू नो, जैसे जैसे आपके पॉपुलेशन बढ़ती गई एंड क्राइम रेट्स बढ़ते गए तो फॉर्ज करना इसको आसान होता था. तो देन research went into one step forward कि let us devise something जो कि बहुत और भी उससे authenticated हो. तो then biometrics came into existence कि person की अपनी identity, you do not need to carry any ID, you do not need to carry any sign or anything, just put your fingerprint, if it matches you are allowed to enter. ठीक है? तो biometric की बहुत सारी ट्रेट्स होती हैं. दिस इज अ फिजियोलॉजिकल कैरेक्टरिस्टिक विच अ पर्सन पोजेस एंड कैरीज विद हिम. ओके, सो इट कुड बी योर फिंगरप्रिंट. फिर फिंगरप्रिंट में भी फॉर्ज होना की पॉसिबिलिटी बढ़ती चली गई. देन आयरिस पे लोगों ने रिसर्च की, ईयर बायोमेट्रिक्स पे रिसर्च की. आयरिस फॉर्ज बहुत कम हो पाता है, बट आयरिस के साथ में नेगेटिव कॉनोटेशन अटैच्ड है. जो कि पर्सन एजुकेटेड है, जैसे आप लोग हैं, हम लोग हैं, तो हमें कोई बोलेगा कि आप आई का अपना वो पैटर्न दीजिए, वी विल गिव. बट थिंक ऑफ रूरल पीपल, वो कहेंगे पता नहीं किस मशीन के आगे खड़ा कर दिया है. हमारे साथ ये इशू आया था जब हमने आयरिस पैटर्न्स कलेक्ट करे थे रूरल लोगों के जाके एट IIT कानपुर. आई वॉज वर्किंग इन द लैब. तो लोग नहीं देते थे, कहते थे नहीं आई विल नॉट गिव माई आयरिस पैटर्न. क्यों दे? गांव वाले लोगों को समझाना ही एक बड़ी प्रॉब्लम थी कि नहीं हम सिर्फ रिसर्च के लिए आपका आयरिस का ये सिग्नेचर ले रहे हैं. वो कहते नहीं हमारी आंख खराब हो जाएगी. सो दीज आर द इश्यूज, पीपल डू नॉट वांट टू गिव देयर सिग्नेचर. अब DNA, अगर DNA विल बी ऑल द मोर ऑथेंटिकेटेड, ECG पैटर्न्स आपके और भी बेटर होंगे, बट ये पैटर्न्स लेना ही एक इशू होता है. मेरा कोई ECG बोले कि आप ECG दे दो, मुझे रिसर्च के लिए बायोमेट्रिक्स के लिए काम करना है, तो वो कहेंगे अब क्यों दें आपको, लाइक यू नो. सो इसको बोलते हैं कि इजीली अवेलेबल ये पैटर्न्स नहीं होते हैं. सो मैक्सिमम रिसर्च जो बायोमेट्रिक्स के एरिया में हुई है इज इन फिंगरप्रिंट्स, बिकॉज फिंगरप्रिंट्स पीपल स्टिल गिव. दे से ओके फाइन, यही फिंगर लगानी है, आई हैव नो इश्यूज. ओके, सो नाउ दिस इज वन फॉर्म ऑफ सिक्योरिटी कि बायोमेट्रिक्स यूज करके हम yes और no कि yes you are authenticated और you are not authenticated. This is very important and हर जगह पे आजकल ये यूज होता है. आई थिंक यहाँ पे भी आप लोग के अटेंडेंस बायोमेट्रिक है ना? Even faculty has to put in their biometrics, so we are all aware of this, you know. And now in even airlines, wherever you go, these things have become very this. Even in your mobile phone, you have face recognition. Most of the iPhones have. You show your face and it will open for you. ठीक है? So now this has become very common. But still, हमारा जो demographic data होता है, like our first name, our last name and all of this is very important. क्योंकि जो अब government system में सारे records आपके हैं, वो सारे कैसे बने हुए हैं? Most of them are validated through your demographic data. कि आपका नाम क्या है, आपके पिताजी का नाम क्या है, आप कहाँ रहते हो, you know. तो जैसे लैंड रिकॉर्ड्स हैं, या इनको अब हम इसमें हम उन पुराने लोगों के बायोमेट्रिक तो ला नहीं सकते. सम ऑफ देम डोंट एग्जिस्ट ऑल्सो, दे हैव एक्सपायर्ड लाइक दैट. तो हम कैसे काम करें? तो दैट इज वाई आधार, चलो आधार तो अब आपके बन गए, सब लोगों के बन गए. UID आपका सबके पास है, बट यूनिक आइडेंटिफिकेशन. बट कुछ डेटाज अभी भी ऐसे एग्जिस्ट करते हैं मेडिकल में, चाहे लैंड रिकॉर्ड्स हैं या गवर्नमेंट के पास में, जहाँ पे आपके पास बायोमेट्रिक्स अवेलेबल नहीं है. देन हाउ डू यू वर्क? then you have to work with the demographic data. What is demographic data? इट इज योर स्ट्रिंग्स लाइक फर्स्ट नेम, लास्ट नेम, मिडिल नेम, या आपके फादर्स नेम एंड ऑल ऑफ दैट, उसी से आपकी आइडेंटिटी डिफाइन होगी. सो दिस एंटायर थिंग विच आई वांटेड टू शो यू इज वर्किंग विथ डेमोग्राफिक डेटा. नाउ डेमोग्राफिक डेटा में इशू क्या आता है, जैसे कि आपके पास 10 लाख लोगों का डेटा है, तो देयर आर चांसेस ऑफ डुप्लीकेशन. लाइक वंदना तो उसमें से 1 लाख हो सकती हैं, वंदना दीक्षित भी उसमें से 50,000 हो सकती हैं, वंदना दीक्षित कौशिक की भी प्रोबेबिलिटी है कि 10,000 हो सकती हैं. नाउ हाउ डू यू डी डुप्लीकेट, मतलब उनको आइडेंटिफाई कैसे करेंगे, you know, how to deduplicate the demographic data. I am saying this is not like 2,000 data or 3,000 data, this is in the order of crores. जैसे हम 135 करोड़ लोग हैं, इसकी डीडुप्लीकेशन की जरूरत कहाँ पड़ती है, गवर्नमेंट स्कीम्स में. जैसे कि फॉर एग्जाम्पल आई हैव अ स्कीम दैट आई विल डिस्ट्रीब्यूट साइकिल्स टू स्टूडेंट्स ऑफ 12th स्टैंडर्ड और 11th स्टैंडर्ड हु आर अंडर प्रिविलेज्ड. तो उसमें मेरे पास, मुझे अब पोर्टल ओपन कर दिया मैंने कि रजिस्ट्रेशन करिए आप अपना. अब तो आधार बेस्ड होता है, पहले की बात कर रहे हैं. तो वहाँ लोग अपना फॉर्म भरते थे और जमा करते थे गवर्नमेंट किसी पोस्ट ऑफिस में जाके. अब आपके पास ऐसी एप्लीकेशंस आ गई 20 लाख, ठीक है, 20 लाख एप्लीकेशंस में उसने नाम भरा, फादर का नाम भरा. अब उसमें चांसेस ऑफ डीडुप्लीकेशन लोग फॉर्ज करते थे, कि एक ही नाम, एक ही फैमिली के 6 लोगों ने, हमने स्कीम दी गवर्नमेंट ने कि एक फैमिली को 1 साइकिल मिलेगी, तो 6 लोग ले लेते थे, और कुछ लोग जिनको जेन्युइनली मतलब है लाइन में, उनको नहीं मिल पाती थी. दीज टाइप ऑफ थिंग्स वर देयर. तो वी नीड टू डीडुप्लीकेट सच डेटा so that everybody gets the benefit. That is where we use these type of algorithms. And this was the live project by the government. They wanted कि हम इस तरह का जो हमारे पास डेटा आता है, तो हम उसमें से डीडुप्लीकेट करके गवर्नमेंट को दें, ताकि वो इस तरह की स्कीम्स में सबको बेनिफिट कर पाए. So that is what this entire thing is, an efficient algorithm for deduplication of demographic data. So this already I have told you. Recognition can be done using 2 traits, biometric or demographic. Biometric is what you possess, demographic is the string based data which you write, which you give. Then biometric data is physiological characteristics like face, ear, iris, fingerprint, etc. And demographic data is data in the form of text or string which can be used for identification. For example, in electoral department, any voter can be identified uniquely with the help of his name, his father's name, his date of birth, and his permanent residential address. That is how we identify ourselves, no? What is my name? Where do I stay? What is your gender? What is your date of birth? When you add these attributes to a person entity like me, you can identify me as Vandana Dikshit Kaushik, right? So this is the demographic identification. Then what is deduplication? In computing, data deduplication is a process to eliminate redundant data to improve storage utilization. This is one thing. Like अगर हमारा डेटाबेस का साइज 2 करोड़, 4 करोड़, 5 करोड़ इस टाइप का डेटाबेस साइज है, इवन इफ इट इज टेक्स्ट, इट इज नॉट इमेज होगा तो आप स्टोर करना ही एक अपने में प्रॉब्लम है. यू नीड अ हाई एंड सर्वर, हाई एंड मशीन टू स्टोर दैट डेटा. Even if it is a textual data, when the size of the database grows, you really do not want to keep redundant data. How many of you have done databases? Studied? कौन से ईयर में आप लोग? सेकेंड ईयर. सो अभी यू विल बी स्टडिंग डेटाबेसेस, राइट? डेटाबेसेस में सबसे पहला बज़वर्ड जो होता है, या पहले लेक्चर में जो आपको टीचर पढ़ाएगा ना, 2 वर्ड्स, कंसिस्टेंसी, रिडंडेंसी. ये 2 वर्ड्स बहुत इंपॉर्टेंट है. कंसिस्टेंसी मीन्स कि आपका डेटाबेस शुड बी इन अ कंसिस्टेंट स्टेट. जो स्टेट डेटाबेस की पहले थी, और जब आपने कोई उसमें प्ले किया, मतलब कुछ डेटा या तो स्टोर किया या रिट्रीव किया या डिलीट किया या कुछ भी किया, उसके बाद उसकी स्टेट क्या होगी वो सेम होनी चाहिए, कंसिस्टेंट, ठीक है। तो कंसिस्टेंसी मेंटेन करने के लिए हम आइदर ऑल और नन प्रॉपर्टी यूज करते हैं, दैट इज कॉल्ड एटॉमिसिटी। या तो पूरा ट्रांजैक्शन हो जाए या रोल बैक हो जाए वापस से। बैंक से कभी पैसे निकाले एटीएम से, कई बार होता है कि पैसे नहीं निकले और मैसेज आ गया, हुआ है? हाउ मेनी? आई थिंक ऑल ऑफ अस, whenever we go sometimes to the ATM, we put in our this card, हमने सब कर लिया, पिन विन डाल दिया, सब कुछ, पैसे आई ही नहीं। शुरू में तो हम डर जाते थे बिल्कुल, अरे क्या हुआ, फिर यू आर गोइंग टू द बैंक, पैसे नहीं आए, पैसे नहीं आए। तो कंसिस्टेंसी कैसे मेंटेन करता है बैंक? आपका 48 आवर्स, मतलब दे से कि इन 48 आवर्स इट विल बी रिट्रैक्टेड। अब तो मैसेज आ जाता है, पहले नहीं आता था, तो यू हैव टू वेट, यू आर वेटिंग कि 10,000 रुपीज़ कहाँ चले गए। तो इन 48 आवर्स द अमाउंट रिट्रैक्ट्स। व्हाट हैपन्स, या तो पैसे मिल गए आपको, आइदर ऑल और नन, इट विल रोल बैक, ठीक है। सो यू विल गेट द मनी बैक इन योर बैंक। This is consistency. What is redundancy? Redundancy means unnecessary duplication of data. मतलब एक ही डेटा की मल्टीपल कॉपीज हैं आपके पास, हम वो नहीं चाहते क्योंकि हम स्टोरेज को एफिशिएंटली यूज करना चाहते हैं, पहली चीज। दूसरी चीज, जितनी रिडंडेंसी होती है उतना ही ज्यादा डेटाबेस को कंसिस्टेंट रखने में प्रॉब्लम आती है। कंसिस्टेंट मीन्स करेक्टनेस प्रॉपर्टी ऑफ द डेटाबेस। व्हाट डज दिस मीन कि अगर आपकी सपोज स्टूडेंट रिकॉर्ड है, वो आपके अकाउंट सेक्शन में भी मेंटेन होता है, वो आपके हॉस्टल्स में भी मेंटेन होता है, वो आपके रिजल्ट मैनेजमेंट में भी मेंटेन होता है। मतलब स्टूडेंट की मास्टर फाइल है, वहीं से आपके मार्क्स फिल होते हैं और सब रिजल्ट बनता है। इवन हॉस्टल्स में आपने कितनी डाइट ली या आप कितने दिन रुके वहाँ पे, अकॉर्डिंगली, है ना। तो अगर स्टूडेंट आया फर्स्ट ईयर में, उसको PSIT से IIT में एडमिशन मिल गया, उसने छोड़ के चला गया, ठीक है। अब आपने नो ड्यूज लेने हैं, राइट। आपने एकेडमिक सेक्शन से अपना डेटा डिलीट करा दिया, बट सपोज वो हॉस्टल वाला नहीं हो पाया और आप फिर बोलो मैं आज 1 महीने बाद आके नो ड्यूज ले जाऊंगा, मुझे जल्दी है, वहाँ पे आपके ड्यूज बन गए, राइट। तो क्या हो रहा है, स्टूडेंट हैज ऑलरेडी लेफ्ट, ही हैज इन्फॉर्म्ड, बट बिकॉज डेटा में कंसिस्टेंसी, मतलब अननेसेसरी रिडंडेंसी थी, आपने उधर से रिकॉर्ड नहीं डिलीट किया, आपको ड्यूज देने पड़ रहे हैं, ठीक है। नोबडी इज गोइंग टू वेरीफाई फॉर यू कि वहाँ पे ड्यूज बन गए, आपको देने पड़ेंगे। तो हम क्या चाहते हैं कि हम एक कॉपी रखें डेटा की, एक स्टूडेंट रिकॉर्ड एक जगह सेंट्रल हो, वो शेयर्ड हो सब जगह, यहीं से डिलीट हो जाए तो सब जगह से डिलीट हो जाएगा। वी डू नॉट वांट मल्टीपल कॉपीज ऑफ द डेटा, वी वांट द सिंगल कॉपी ऑफ द डेटा। तो रिडंडेंसी अवॉइड करना बहुत इंपॉर्टेंट होता है। सिमिलरली ऐसी गवर्नमेंट स्कीम्स में या जहाँ पे आपके करोड़ों का डेटा आपने इकट्ठा करना है, तो वहाँ पे आपको यू डू नॉट वांट डुप्लीकेशन, क्योंकि हर उस स्कीम का बेनिफिट सबको मिलना चाहिए, इट शुड नॉट बी गिवन टू 1 person, दैट इज वाई वी डू नॉट वांट रिडंडेंट डेटा, राइट। So in the deduplication process, duplicate data is deleted, leaving only one copy of the data to be stored along with reference to the unique copy of the data, ठीक है। So in this paper or in this work, by demographic data of an individual, we mean a record consisting of 2 strings, that is the given name and the surname. हमारे इस current काम में given name और आपका जो surname है, these two we want to keep and that too unique, okay. Demographic deduplication process determines whether there exists any set of records in the demographic database which are matched with the record of the query data within some tolerable range so that the query could be a potential duplicate. Now what do we do? Suppose I am Vandana Dikshit Kaushik, okay. Now I want to give benefit to my sibling. उसका मैंने नाम थोड़ा सा उल्टा कर दिया, वंदना कौशिक दीक्षित। तो मतलब हम ये चाह रहे हैं कि ऐसे जो नियर टू डुप्लीकेट्स हैं उनको भी डिलीट, मतलब उनको भी डुप्लीकेट कर दें, so that the maximum, तो we had used certain phonetic rules of reduction. वो phonetic rules of reduction were developed by us. I think I am audible? I teach class. surname. So need for demographic deduplication. Maximum information stored about people is demographic. Biometric information अब हम रखने लगे हैं in your generation. बट जो अभी तक हमारे पास इंफॉर्मेशन गवर्नमेंट के पास या जितनी भी हैं, दिस इज डेमोग्राफिक इन नेचर. डेमोग्राफिक मीन्स हम उनका नाम, एड्रेस, फोन नंबर, और आज भी हम डेमोग्राफिक डेटा लेते हैं सबसे, राइट? कोई भी आप फॉर्म भरते हो तो पहले अपनी डेमोग्राफिक इंफॉर्मेशन देते हैं ना, आपका नाम क्या है, आपका एड्रेस क्या है. तो जितने भी डेटाबेसेस हमारे बने हैं हिंदुस्तानी लोगों के, सिटीजन्स के, दे आर डेमोग्राफिक इन नेचर. सो वी हैव टू कैच पीपल कमिटिंग फ्रॉड हु रजिस्टर मल्टीपल टाइम्स इन द सिस्टम टू गेट एडिशनल बेनिफिट्स. Integration of information stored in databases of multiple organizations to provide one common view. Okay, reducing redundant storage to improve memory utilization. This is the need why we need to go in for demographic deduplication. So this may seem a simple problem, but this is a very complex in nature. How to remove redundancy in this kind of database? We are a population of in India I guess 140 crores or something. अब इन सबों की इंफॉर्मेशन हमारे पास काफ़ी सारी डेमोग्राफिक है. अब उसमें से हम डीडुप्लीकेशन करना चाहते हैं, राइट? समथिंग लाइक दैट. For any new demographic data, a negative background search is performed. So how do we proceed with doing this demographic deduplication? So we need to do a negative background search to obtain all close matches. जैसे वंदना कौशिक दीक्षित, वंदना दीक्षित कौशिक, वंदना की स्पेलिंग में ए और एन शिफ्ट हो गया, स्टिल यू विल प्रोनाउंस इट एज वंदना. कोई एन ए लिखता है, कोई डी ए एन ए लिखता है. सो एनी काइंड ऑफ क्लोज मैच. ओके, so for that to accomplish this, every string is considered to be found in the database is if any of the following criteria is satisfied. Identical strings in the database, strings having similar phonetics but difference with alphabets. Like कई लोग एक ही वर्ड को अलग अलग स्पेलिंग्स में लिखते हैं, ठीक है? लाइक फॉर एग्जाम्पल संजीव, you know, Sanjeev SANJIV, SANJEEV. तो नाम हम बोल रहे हैं संजीव, but we are spelling it in a different way, right? Strings having similar phonetics, ये हो गया. Strings which can be constructed from new string by few transformations like insertion, deletion and substitution. कुछ words को आगे पीछे कर दें तब भी उसका pronunciation phonetically same होगा, like that. So previous algorithms क्या थे? Data deduplication has been approached previously using machine learning algorithms. In these algorithms, a labeled set of duplicates and non-duplicates is provided to learn the deduplication function and is used to predict on testing set. These algorithms depend heavily on providing an exhaustive and diverse set of duplicates and non-duplicates that bring out the subtlety of the deduplication function. These were certain previous algorithms. Proposed algorithm what we have worked on, which is published, is demographic data considered. क्या करा है हमने? consider the name, surname and the ID of an individual. These are the three things which we have taken care of and avoided all deduplicate. मतलब we have eliminated all duplicates. The proposed deduplication search is based on the approximate string matching algorithm called Lavenshield's edit distance. It deduplicates based on comparison, based on reduced generic names instead of original name strings. Original name strings जो हमें दी हैं, मतलब जो हमारे डेटाबेस में है, उसको हमने रिड्यूस किया है जेनेरिक नेम्स में. जैसे मेडिसिन्स में आप सुनते हो ना, जेनेरिक नेम्स ऑफ मेडिसिन्स. We reduced the given names, जो names हमें मिले थे, demographic data मिला था, उनको generic names में using our own algorithm, that is phonetic rules of reduction लगा के हमने generic names में reduce किया था. Okay, then generic name is calculated from original name by applying certain phonetic rules of reduction. Edit distance, this is just about the algorithm, so I will just go there. For example, NED Amit and Ankit, इसमें कितनी सिमिलैरिटी है आपकी? हाउ मेनी स्ट्रिंग्स आर मैचिंग, हाउ मेनी अल्फाबेट्स आर मैचिंग? Normalized edit distance obtained by 2 substitutions. अगर हम 2 substitutions लगाते हैं तो हमें सेम स्ट्रिंग सेम अल्फाबेट सेम नेम मिल सकता है, ठीक है. फन और फनियर में normalized edit distance obtained by 4 insertions. 4 insertions लगाएंगे तो we'll get the same word. So I'll not go in for the algorithm because it will be too heavy for you guys. Just wanted to share you with the work. Phonetics rules of reduction. It has been observed that one can write or pronounce a name in several ways, and as a result, the database size becomes unnecessarily large, which leads to very large amount of searching time. जितना बड़ा आपका database हो जाएगा उतना बड़ा सर्चिंग टाइम लगेगा. अब आज की डेट में क्या होता है कि हम लोग अगर कोई मूवी देख रहे होते हैं या हम कोई क्वेरी करते हैं, जैसे www समथिंग हमने टाइप किया, वी वांट द रिजल्ट इंस्टेंटेनियसली. सबको लगता है ना कि अरे यार ये तो लैग आ रहा है, मूवी नहीं अच्छी चल रही. तो कई चीज़ें तो नेट की प्रॉब्लम होती हैं कि इंटरनेट इज स्लो और समथिंग. कई बार क्या होता है कि आपका डेटाबेस साइज इतना ह्यूज है कि स्ट्रीमिंग ही नहीं हो पा रही है, राइट. सो we want the optimized database so that you get to see the response time is less, because सब कुछ रियल टाइम में काम कर रहे होते हैं हम लोग. सेम मेडिकल इमेजिंग में भी है. सपोज अ डॉक्टर इज सिटिंग इन US and he is supervising the operation which is done at Kanpur. It happens nowadays, it is happening. Okay, you can have a specialized surgeon who's not in India, who's sitting in some real time. Now he is supervising the surgery going on here in Kanpur. अगर वहाँ लैग होगा तो क्या होगा उस बंदे का? He'll go. So we do not want such things. तो ऐसे cases में more than internet, whatever, अगर suppose he is trying to show a diagram from his computer sitting in US, अगर वो डायग्राम अपने कंप्यूटर से दिखा रहे हैं और वहाँ पे उसके डेटाबेस में इट इज़ नॉट ऑप्टिमाइज्ड, तो यहाँ के डॉक्टर्स परसीव नहीं कर पाएंगे ना रियल टाइम में. सो हाउ दे विल अंडरटेक द सर्जरी. सो इन सच सिनेरियोज यू रियली वांट योर डेटाबेस टू बी वेरी एफिशिएंट एंड वेरी ऑप्टिमाइज्ड, ओके, सो दैट द रिस्पॉन्स टाइम इज लेस. So in order to reduce the search space in the database, each name is reduced to its generic name. For example, name like Ashish, Ashish, all these. See, the pronunciation of all of these are same. Ashish, Ashish and all. So we will reduce them to ASIS, ASIS. Okay. Some phonetic rules of reduction on each name string can be defined to find its generic name. So this is how these are designed by us, and we had patented also this phonetic rules of reduction. Now what is the data structure which we have used? It's a very simple data structure. Phonetic reduction rules to convert a name string into a generic name string are based on the above said rules. The rules which are these, which I'll not elaborate here. There may be several name strings which are converted into single generic name. जैसे आशीष एक आपने generic name में convert किया, ऐसी कोई और word हो सकता है which is similar, which can be also converted to ASIS, जो कि हमारा phonetic rules of. तो इसके केस में क्या करते हैं? Further, one can observe that there may be several individuals having same names but different IDs. So one can represent a bin in the form of singly linked list. What happens is कि एक इंडिविजुअल है आपका जिसका जेनेरिक नेम से, मतलब 4 लोग हैं जिनका जेनेरिक नेम सेम बन रहा है, ठीक है, उनकी आईडीज अलग है क्योंकि वो अलग अलग नेम स्ट्रिंग्स हैं. तो उनको हम क्या करते हैं, बिन में रखते हैं. मतलब एक सिंगल लिंक लिस्ट बनाएंगे जिसमें वो सारे जेनेरिक नेम्स आपके एक लिंक लिस्ट में होंगे. The proposed approach works in 2 modes. First is the enrollment and next is the verification. At enrollment stage, the reduced name of the name string is used to get the desired bin. If there exists a field in the node of the list having the same name string, then the ID of the name string is inserted in one of the empty ID fields. Otherwise, the new node of the name string and its ID. बेसिकली वॉट वी आर डूइंग इज सेम जेनरिक नेम आ रहा है अगर, तो हम उसको सिंगल लिंक लिस्ट में उसको एक में रखते हैं, दूसरा आएगा तो एक दूसरी नोट बना देंगे, ठीक है. Thus, during enrollment, a demographic database is converted to an array of records where each record is a singly linked list with a header node marked by the reduced name. Each node in the linked list has several IDs, one name string, and the other is the link field. So this is the flowchart, enrollment, bin creation and filling. We have the demographic database. Then we select record number I, then first name और last name में उसको split करते हैं, then phonetic rules of reduction लगाते हैं. After that we get the reduced first name, that is RF1, and then we get the reduced last name. Then we create bin if it is not present. In the list if it is present already उस नाम से तो उसको उसी में आगे attach कर देते हैं. If it is not present, we create a new bin like this. Then this process goes on with the phonetic rules of reduction. We create different bins. Then verification. Verification is nothing but duplicate detection in the demographic database. Each name string of the query demographic data, that is first name and the last name, like this we have shown you, na? First name and the last name, is reduced, and all bins having reduced names whose normalized edit distance from the reduced name and the name string of the query image is within the tolerable range are selected for further processing. अब हमारे पास bins बन गई. We have the first name, we have the last name. Now given any query image, मतलब ये verification, enrollment हो गया. We have created the reduced database. Now whenever we get a query image, we search from the edit distance in the tolerable range. अगर उसमें से कोई present है आपका, तो we will not keep that particular field now. We will, अगर नहीं present है, then only we will keep that. Okay, because we want to deduplicate. We do not want to keep the redundant data, right? It can be noted that the edit distance enables to capture two similar strings that cannot be identified simply by using the phonetic rules of reduction. It can effectively detect all those duplications where there are some modifications in the string. All name strings in these selected bins having the normalized edit distance from the name string of the query data is less than the tolerable range. Okay. So this is the algorithm basically. Let Q and X be the demographic data of the query and of the probable candidate in the database respectively. So what is Q? Q is your demographic data and X is the candidate basically. One could have obtained sum of the normalized edit distance of given name and surname between Q and X to find its matching score. But individuals may provide inconsistent data. That is, he, she may have interchanged the strings of his or her name. Why? Because they want additional benefit, right? तो वो अपने ही name strings को change कर सकते हैं. In that case, this may be due to attempt to fraud the environment or to make use of different styles of writing. In order to tackle such types of scenarios, normalized edit distances between every pair of name strings have been considered. So I'll show you some of the experimental results because the algorithm and all will be too complicated for all of you. To analyze the performance of this particular work, a demographic data consisting of 4,85,136 individuals with giving name, surname and ID is considered. Firstly, enrollment is done in which the given name and surname is reduced using phonetic rules of reduction. So, given name, number of bins हमारे कितने बने थे? 43,941, surname 27,000, minimum bin size and this. So, reduction percentage. After reducing those names, first name or surname में reduce करने के बाद, reduction percentage came up to be 90.94% and 94.40%. So when we compared it with the previous algorithms, जो machine learning use करके demographic data पे deduplicate किया था, this was much higher. Because it is not, precision in case of demographic deduplication is not that high. It is very, very complicated. सो दिस इज वन एग्जाम्पल. जैसे यश मेहता है, टॉप मैचेस अगर हम यश मेहता में से जब हम अपने डेटाबेस से सर्च करते थे तो टॉप मैचेस वर लाइक दिस, ऑल दीज वर मैचिंग. तो दिस इज द पेनिट्रेशन रेट कि इतना पेनिट्रेट करके दीज वर द टॉप मैचेस विच वी हैड गॉट. These are some of the results. Now conclusion. Penetration rate for a given query is the average fraction of the total database scanned to get top K matches, best matches. Penetration is directly proportional to the threshold. ठीक है, जितना आपका थ्रेशोल्ड बढ़ेगा उतने ज़्यादा आपको मिलेंगे, राइट, उतने ज़्यादा क्लोज मैचेस मिलेंगे. जितना थ्रेशोल्ड कम होगा आपका उतने बिल्कुल एग्जैक्ट मैचेस मिलेंगे. तो ये आपकी एप्लीकेशन पे डिपेंडेंट होता है. कई बार क्या होता है कि हमें एग्जैक्ट मैच चाहिए होता है तो हम अपने थ्रेशोल्ड को बहुत स्क्यूड रखते हैं, छोटा रखते हैं, क्योंकि हमें वंदना दीक्षित कौशिक ही चाहिए, राइट, क्लोज टू दैट. तो वी विल स्क्यू आवर थ्रेशोल्ड. बट समटाइम्स हमें कंपैरिजन करना होता है किसी भी चीज़ का, तो हम अपने थ्रेशोल्ड को थोड़ा ज़्यादा रखेंगे कि क्लोज टू वंदना दीक्षित कौशिक कितने मिल जाएंगे, राइट. सो डिपेंडिंग अपॉन दैट वी पेनिट्रेशन इज व्हाट डू यू टॉप के मैचेस डेटाबेस से निकालने को वी कॉल दैट पेनिट्रेशन रेट. ओके, इट कैन बी inferred that hit rate improves greatly by increasing thresholds but at the cost of increased penetration. This work has proposed an efficient deduplication algorithm for demographic data. It is a challenging task when two name strings with phonetical and other random differences are referring to the same individual. Simple phonetic reduction and exact matching cannot identify potential duplicates due to their rigidity. Thank you.
Thank you, ma'am. Your knowledge and wisdom have surely left.
Any kind of questions for that in case you guys have.
Students, if you have any doubt, any questions, you may ask.
See, why I wanted to discuss this was because आगे चल के you want to be going for research. So, if you want to, I mean, you are open to work in the areas of databases, in the areas of biometrics, and if you want any kind of support or cooperation, I am just here in HPQ, that is in your city. So, we can collab. My students can collab with you guys. So, you are open for that. Any kind of any query or any question if you have.
It's a very good opportunity for you students. If you have any idea, anything that you want to discuss, that you want to ask, I'm here for you.
You can take my email ID from sir, you can take my phone number from sir, and you can just give me a call and I am available 24/7 for students. No issue. Thank you.
Could be a little bit louder, beta. Yeah, you come
Mike,
forward. Come
forward.
You have mic? Okay, Divya, just take this mic. Yes, students.
Ma'am, like there are several individuals with the same name, like you said, there can be several Vandana Dikshit from the data you collected, but your data checks for same matches. So how do we identify that these two Vandana Dikshit are the same person and they are not different?
That is what we have done. See, if you have the different ID, same name can be there. If the IDs are different, we keep them in the same bin, but in a different field in the single linked list. अगर वो आपका वो अलग-अलग नाम है, वो अलग ID है, ठीक है? उसी केस में हम उनको सेम उसमें रखते हैं. अगर उस वॉच करके मतलब जैसे रिड्यूस करने के बाद जेनरिक नेम में अगर सेम पर्सन ने 2 बार फॉर्म दिया, जैसे ऐसा हो सकता है ना कि मैंने स्वैप कर दिए अपने और मैंने बेनिफिट एक्स्ट्रा लेने के लिए 2 बार फॉर्म भर दिए, तो हम जब जेनरिक नेम में उसको रिड्यूस करेंगे तो आइडेंटिफाई कर लेगा हमारा एल्गोरिथम कि ये सेम ही पर्सन ने 2 बार नाम.
मैम, उनकी आईडीज मैच करनी चाहिए या फिर डिफरेंट होनी चाहिए?
नहीं, आईडीज आपकी मैच, देखो आईडी भी लोग सेम अलग कर देते हैं ना भाई. व्हेन यू आर फिलिंग अ फॉर्म लाइक दिस, जब आप बेनिफिट लेने के लिए तो कई बार आप अननेसेसरली सेम टाइप की 2 आईडीज दे दोगे. IT can be different, but चूंकि हमने phonetic rules of reduction लगा के उसको generic name में reduce किया हुआ है, there will be no possibility of a match. हाँ, but accuracy उतनी ज़्यादा नहीं, मतलब वो demographic data में हमेशा होता है. It can never be at that level जो biometric data की accuracy होती है. That can go up to 99% or something like that. But in demographic data, if you can achieve an accuracy around 90, it's pretty much good.
Yes, ma'am, I get it. Thank you, ma'am.
Question.
बेटा एक मिनट माइकस.
Suppose at the time of collection of data, it's a female, and before marriage, she is using her surname. Suppose it's Vandana Dikshit, and later on she has deleted her, reduced her surname or changed, and then how would we identify it's the same person?
नहीं तो in that case क्या होगा कि जब आपने enrollment करा ना, तो आपका enrollment के time में वो एक अलग से ही बिल में जाएगा पहले, ठीक है? But then after generic name में reduce करते करते जब हम उसको algorithm को 3-4 बार will run ना, तो it will reduce to a single bill.
But generic name will be the same, but suppose it's
See, आपके first two names same आ रहे हैं ना? First two names जब आपके same आएंगे तो जब आप उसको reduce करोगे generic phonetic rules of reduction लगा के, तो it will go to the same bill only.
okay, actually currently she is not using that surname, and some other surname she is using. Then
But in that case ID will be same, no? ID तो same होगी ना? तो ID से match कर लेगा.
Any further questions? Yes. Wait. Students.
Ma'am, what is tolerance? If there is a different ID and same name and surname, then they are two different individuals, right? And what is this the tolerance? Like if we can insert 2 or 3 strings in that, so how much is the tolerance for checking it? If
नहीं, see, what I told you in the last slide, the threshold or the tolerance is depending upon your application. अगर आपको अपनी data, see what we have done is deduplicated the demographic data and stored it. Now, based on your application, if you want top 3 matches, मतलब आप चाह रहे हो कि हमें उस name से closest 100 matches आए, करोड़ों का database, तो उसमें आपकी tolerance ज़्यादा होगी, मतलब that fee will be, the threshold will be high, so that you can fetch more information from the database. If you want only top very close matches, then your tolerance will be skewed, कम होगी. Based on that, उतना ही penetration होगा. It is directly proportional. Penetration rate आपका और hit rate is directly proportional to your tolerance. The more the tolerance, you will get more matches. तो जैसे हमने यश मेहता आपको दिखाया था, हमने अगर टी ज़्यादा रखा है, थ्रेशोल्ड ज़्यादा रखा है, तो यश मेहता समथिंग, यश दिलीप मेहता सारे आ गए. अगर हम बिल्कुल क्लोज यश मेहता के क्लोजेस्ट टॉलरेंस कम रखेंगे, तो वेरी क्लोज टू यश मेहता भी मिलेंगे.
Thank you, ma'am.
Thank you. Any other question? Okay. Thank you so much, ma'am.
Thank you, ma'am. Your knowledge and wisdom have surely left a profound impact on all of us. Now, I would like to request all of you to extend a heartfelt welcome to our next keynote speaker, Dr. Avinash Lahegere. Sir is a distinguished member of IEEE and Assistant Professor of Electrical Engineering at Indian Institute of Technology. Sir completed his master's degree in Electronics and Communication from the PDPM Indian Institute of Technology, Jabalpur in 2015 and received his PhD in Electrical Science and Technology in 2018. With nearly 5 years of experience as a device compact model engineer, Sir has received numerous accolades including Spotlight and Appreciation Awards during his tenure at GF. His contribution to the field are reflected in his publication in esteemed journals such as IEEE Transaction on Electron Device and IEEE Transaction on nanotechnology. Sir's research focuses on semiconductor devices and circuits, with particular emphasis on advancements in von Neumann computing. His expertise extends to low power, low voltage beyond CMOS logic and memory devices and associated materials. As an assistant professor at IIT Kanpur, Sir plays a pivotal role in steering the discourse in electrical engineering. His impact extends beyond the classroom with roles as a reviewer of reputable publications and a technical program committee member for GUCON 2022. Sir, I request you to kindly come forward and share your valuable insights with us. Sir, please.
Hello. Yeah. So, good afternoon, everyone. And before I start, I would like to thank you all for giving me this opportunity to speak about some of the recent work which actually I am carrying out in my as an assistant professor in IIT Kanpur. I am a very new professor, just joined last year. So this is something what one of my BTech students has carried out in given his UGP program. The topic which I have considered here is actually not that much popular in terms of academic research.
I just want to make an announcement.
Yes.
Sorry for the disturbance, sir. Okay, so students, the lunch timing will be extended, so don't worry about the recess. Sir is going to give a very important talk regarding our today's conference topic theme. So please focus on that, and the recess timing will be extended. So don't worry about your lunch. Thank you.
Okay. So, okay.
Want hand mics? We can give it whichever you are comfortable.
Yeah, that is also fine. No issue.
So it's totally up to you in whichever form you are comfortable.
Okay. So this topic, as I was saying, that in terms of academic research area, not many one are working in this area. At least if I say in India, there are only 2 people. But if you look in terms of industry, this is something which is like industry are very much interested. And this is something the area, they don't have any expertise, and the reason that's why I bring this topic. This topic, before we actually go to the technical details, we will try to understand this topic and its analogy through the nature. So the topic is actually electrostatic discharge. We are not going to go in so much research, but we just try to understand what actually the electrostatic discharge and where are the opportunities where the students can work. So here are the outlines of my presentation. So before we start the actual discussion about the ESD, I would like to give you the motivation that why one should pursue the field, or let's say why they should pursue their career in semiconductor devices. Then we look into that what are the pros and cons when we are going from a different devices, or let's say from one technology node to another technology node. And then we'll start talking about that what actually ESD, what are the challenges, how can we mitigate, and how can we overcome all of this. Along with that, we will look into that what actually in the future. So the first thing which actually comes everything in a mind that I think so many of us have talked about, that especially the BTech students are more focused towards the placements. There are not many ones who are actually inspired or want to do in the academic because they want to get settled down earlier. So one of the quiet reasons that why one should pursue in the career in the semiconductor devices is that the stable employment. Now if you look the chart what I have carried out here is actually the market growth. Now despite the COVID situation, as the COVID hit the different countries and the world, we see that there were several things which actually have happened in the work from home. People were purchasing laptops, tabs and everything. So that actually require and have to get the more semiconductor chips and all. It has been forecast that in the upcoming, in 2026, this market going to be more than 2 times again. Now, if you look the different components, like within semiconductor devices, there will be a memory, there will be some analog devices, analog circuit, digital circuits, there should be some RF transmitters and all. So everything is actually going too far. Now, in terms of like if you look the overall market, or let's say if you are purchasing electronic chips, the number of electronic components is going to be increased again and again. So this is what the one motivation that why one should pursue his or her career in semiconductor devices. Coming to the students who are actually want to go for the future studies, like they want to be in the opportunities and want to do the academic research. Now this is the landscape that we actually started from something is like a planar devices. You might have seen in your basic electronics courses, but as we are actually going from one generation to another generation, it is not possible that we can actually stick with the same device. So there are multiple research and multiple innovations are happening, not only at the architecture level, but at the material level also. And all these new devices and new materials actually requires a significant research. Not only the academic, but the industries are also actually exploring all these things. So as academic research, if you actually get into this field, not only you are going to help yourself, but you are maybe helping the industry who are going to make the new chips and the new generation product. So these are the two motivations that why one should pursue their devices. Now, coming to in terms of how this whole analogy works. So what we actually want as a consumer, that if I'm going from one generation to another generation, what I want that whatever the chip I am purchasing, okay, it should have a higher performance, it should have a more applications, but at the same time what I want actually, I don't want to pay the lot of money, okay, and this is something is actually governed by called as a Moore's law, okay. Now, if we look this law, what we actually see is actually as the number of circuits component in a given chip are increasing, but the cost which we are predicting should decrease at that rate, but it is actually increasing. So there is actually an economical role. That economical role actually says that if you really want to get the number of chips, or let's say number of components in a per chip very high and high, means if I want to get the more performance and the more applications, what actually I require is the market. If the market says that this is what my demand, this is what the consumer requires, they have to spend the money. That money will help us to boost our technology and the industries. And that's how this whole cycle, and then we can pull that more number of chips and the more number of performance in a given area by using by paying the reduced cost. Now, as I was saying, that the ultimate goal of schooling is actually the making the things cheaper. Now it can be in terms of functionality, it can be in terms of the performance, it can be in terms of the power consumption and all. But at the same time, when you're actually having making some advantage, you also have some disadvantage. Now disadvantage can be like when we go from very reduced geometries and all, you actually have a huge power consumption, which can be detrimental to your chip. Now, there will be several other effects which are very detrimental to your devices and circuits. So ultimately is the reliability of integrated chips or the circuits are very much important, which is actually one of the pillar of the industry. Without, if I say that without any reliability test, no industry can sell their chip to the customer. So they have to find, or they have to actually fulfill some reliability test. Now, this is actually the overview of a semiconductor chip. Now what you see is actually here is just a picture, but inside that there's several many things. Now it has some analog circuits like a power amplifier, or maybe you have heard some ring oscillator and all. It also has some RF block. RF means the radio frequency block, which is actually the transmitter, receiver and all. Along with that, it is actually made of a device which is called a FET. Now this FET actually has several reliability challenges. Now among these challenges, as I was saying, that my topic is actually the ESD. Now when we talk about the ESD, it is actually responsible around 72% failure of the devices. And that is why the industries are actually so much focusing on that. How can we mitigate? How can we actually avoid the EHD so it cannot actually damage my circuit or my chip? So that is the one thing. Now, in terms of like if you say the consumer electronic markets where the chips are getting more, so in all these areas, the semiconductor chips are very, very important. And that is where that semiconductor chip needs to be reliable enough if we really want to pursue or if we really want to give the money to the customer. Now, before we actually start discussing the physical or let's say the technical, the picture is actually something which is the analogy people use for to define the EHD. I think so many of you have seen such phenomena in the nature, especially in the rainy season when the light strikes, correct? You might have seen this thing that when you have a rainy season, there is a thunder. Now, have you tried to understand that what actually caused this thunder? So there is actually a physics. The physics is that typically we actually talk about in semiconductor device like electron or the holes, means positive charge and the negative charge. Okay. Now, when this thunder happens, there will be a positive charge and the negative charge, and there will be some separation of the charge. Now, your sky is actually work as a one electrode, and your earth or let's say the ground is actually the another electrode. So you have a two metal plates, and in between your air is actually a dielectric material. Now, you can consider that when this charge separation reaches to a certain threshold voltage or when it reaches to a certain limitation, it actually strike in terms of thunder. And the EHD is very similar phenomena. Now, I'll give you one more analogy. You might have observed in your daily life and sometime that when you are actually walking on a carpet and if you rub your shoes over the carpet, what actually happens, your body will get charged, and the moment you touch any metallic knob or let's say the door knob, suddenly you feel some kind of a shock. Have you observed something in your life? That is actually called as a EHD. Now, we want to see why this EHD is actually important in the electronics chips. So, moving to that, this is actually the physics which actually defines why and what actually is happening. So, the EHD is actually a tri-bioelectric effect. It says that when the two dissimilar materials comes in a contact to each other, there is always a possibility that one material get charged, another material get discharged. Now, when this charge separation will help, and the moment you touch the electronic chips, it actually generates a huge voltage. And that huge voltage is actually something which is detrimental to your electronic chips. So, now if you see this rating, so these are some experimental results or the experimental observation that people have kind of find out that depending upon the environment or depending upon the presence of the country, the moment you see this amount of voltages you are actually using. Now you will be wondering that the mobile and the laptops we are using and the chips what we have inside our mobile and the laptop, they actually are working in the supply voltage of 1 volt or maybe 0.7 volt. But what we are talking here is that when EHD happens, it actually generates a 35,000 volt. This is too huge. So that is why people are worried about that, okay, this something, it's huge voltage is coming. How can we mitigate? How can we remove all this thing? So, so this is a picture like where we are showing that. This is a person who actually has a rubber shoes and then he was walking on the carpet. The moment he was rubbing his shoes over the carpet, he got actually energized and somehow unwantedly he actually touched the integrated circuit or let's say any electronic chips. Now when he touch actually the electronic chips, I'll show you some pictures which actually show you that what happens when it touch the electronic chips. But to understand then how it is actually related to the field effect transistor, these are some ratings that when we use this field effect transistor, which is a gate oxide as a silicon dioxide as a dielectric material, and when a person is charged by around let's say the 10 megavolt per centimeter, and you have a roughly thickness of the gate oxide is actually 10 nanometer, it actually leads to a 10 volt. Still it is a pretty huge volt, because I am talking here, the devices we are working in the 1 volt. So it's 10 times. So this 10 times volt is actually detrimental. So these are the results, which are the experimental results. So what you see is actually when the person who has a 10 megavolt voltage, when he unwantedly touches the semiconductor chip or the electronic chip, it actually generates a huge current. Now, these wires are actually the metallic wires, which are very, very thin, okay? So when a huge current actually flow from these thin wire, they actually generates a heat. Now, that heat may be very much higher than the capability of the wire can carry, and when this huge heat will generate, what you see is actually the metal wire will disappear. Now, if there is a disconnection in your wire, you won't be getting your chip working, correct? The another thing is that it creates a hole. So when you are actually applying a very high voltage to a device, it actually burn your chip. So these are the experimental results we observed during the experiments, and these are the real phenomena, and that's why people are actually interested that how to avoid. Now, coming to when we are working, like let's say if I'm testing my chip, so someone has given me the chip, okay, and then I want to test the chip. So when you are actually testing the chip, to avoid this EHD kind of thing, you actually given so many equipments. So this person is actually what he is trying to characterize his chip. Basically, he has given a chip and he asks you to that you just plot the voltage and current. But somehow you also get energized, okay, unwantedly. So during the working or let's say testing process, you actually given a lot of new things. So you have given a bunny suit. You also have given some EHD safe clothing. There will be a wrist strap. So these actually the equipments people use when they are testing. And the purpose of these is actually just to, whenever there is a huge voltage which is unwanted or which is actually not required for the semiconductor chips, these equipments will help us to remove that extra stress or remove that extra voltage so our chip can work properly. So this is actually at the working side. But what about at the circuit side? Let's say unwantedly, or if I am not wearing all this thing. So there needs to be some another protection which should go with the circuits. So that is what we are now going to talk. So let's say this is my basic circuit. It has a supply voltage VDD and it is a ground pad, and there is an input output from where I will be giving the input and taking the output. Now, since this circuit does not have any protection right now, so there is one more thing like people do to protect the EHD is actually very simple element, that is the diode. I think so many of you have heard about what actually the diode, and you know the process that when it actually get the 0.7 voltage, it actually turns on, correct? So diode is actually one of the simplest example to use as a EHD protection. So along with your internal circuitry, they actually creates a diode, series of diodes, along with there is a power clamp. I will explain you that how this diode works and how this power clamp work in the next slide. So suppose I have a EHD voltage which is actually coming to my input pad, okay. Now this EHD voltage, I don't want that it should encounter with my internal circuit, which is my main circuit, because that EHD voltage is actually unwanted. So whenever there is a voltage of 0.7 higher and that above, this diode will turn on, and that EHD stress will actually get discharged using this VDD to the power clamp. Similarly, if there is a negative voltage on that input-output pad, so your bottom diode will start conducting, and as a result, the negative stress will go away. But what about if the EHD is actually coming to your power supply? Means you are giving the 1 voltage supply, but unwantedly it actually becomes 1000 volts. So that power clamp is also a device which is actually a series connection of a multiple diodes. It needs to be a bigger, it has a higher driving strength in terms of current handling capability. So that power clamp will turn on and it actually removes all the stress. So this is how actually people does the protection in terms of the EHD for the internal circuitry. Now, this diode actually comes in the category of the snapback. Okay, I really don't want to go actually what actually is a snapback, but just consider this is the first kind of a EHD protection is the diode, which is actually a snapback device. So typically the way we characterize in the industry is actually we look into the voltages and then look the current. So you have a VDD, which is actually your operating voltage, means if my circuit, internal circuit is working below VDD, then it is safe working. Now there is actually a breakdown regime. This is actually called as a oxide breakdown, means if I am applying a voltage above than oxide breakdown voltage, means my device is completely gone. Means there is no guarantee and there is no possible way that you can further use the device in circuit again and again. Now in between what you have is actually EHD design window. So as I was saying, your EHD device or EHD circuit should not be triggered below VDD because it gives you the false triggering, but it should also not be triggered above breakdown voltage because there is no sense of the having the EHD. So it must operate within that EHD design window. And this is how the typical characteristic of a diode looks, which has a turn on voltage of 0.7. Now the advantage of this diode based EHD protection is actually that it is very simple to realize. Okay, it's just a simple diode. It can be easily fabricated in terms of real process and all. But the problem is that it has a very small trigger voltage, that is of 0.7. So if something is bigger than that, either you require a series of diodes. So you, rather than having a one diode, you put a multiple diodes in a series. So its turn on voltage can be more than 0.7 voltage. So that is one thing that people don't want to use the diode as a EHD protection. So people actually have come up with that. Why don't we use the MOSFET itself? Because my main circuit is actually made of the MOSFET. So rather than having a multiple diode as a EHD, people just say that, okay, let's use a single MOSFET big enough, which can actually handle that much current and that can give you the protection from the EHD. So this is how the people have come up with this kind of a circuits. So in the previous slide, you have seen that I have a 2 diode. So rather than now having a 2 diode in a series, now I am just using a simple MOSFET. So same principle, but this time the characteristic is very different. So this MOSFET actually has a BJT also. And because of BJT, its characteristic is something like a snapback kind of thing. So don't go, we really don't want to know right now that what actually the physics, but if you are interested, then you can definitely mail me. I can explain you the what actually caused this kind of a characteristic. Now, there are several points, several things which are very important here is actually, so it has some trigger voltage, it has some holding voltage, which because it has some BJT there inside the MOSFET, and it has actually a one VT2 point, which is a thermal breakdown. So whenever the EHD occur in the circuit, it actually leads to a heating. So it has some kind of a thermal breakdown point also. So in terms of advantage, as I was saying, so rather than having a multiple diode is there, you just coming up with the one simple MOSFET. But the problem is coming with the MOSFET is that it requires a number of process step modes. So making a simple PN diode is much easier than the making a NPN transistor. So number of process steps will increase. As a result, the cost you are paying is also getting increased. So these are the two methods. Now coming to the in terms of like how people characterize this thing in the industry, because we are here to understand that why and how the industry are characterizing. So there are industry standards which I will be talking here. So there are two methods people actually use in the industry very widely. That is, one is actually called as a transmission line pulsing. So it's all these are specific to EHD only, and there is a one actually is called a very fast transmission line pulsing. So TLP and VFTLP are the industry standard methods which are used to characterize the EHD devices. Okay, the major difference is just in terms of the rise time and the pulse width. So very fast, as it says, as its name suggests, so it has a rise time of in picosecond, and there is a transmission line pulse, it has a rise time of 10 nanosecond. And this is actually the setup people use in the industry to characterize the EHD device. So you actually give a current pulse, a square current pulse to the device. So DUT is actually device under test. Okay, so these are the industry terms. And when you give the current as an input, at the output you actually measure the voltage. It is not the simple voltage, it is actually the average voltage, because you are giving a current pulse which is actually in the transient domain. So you are actually giving a current pulse with the time thing, okay? And this is actually how the output will look when you take the average output of the voltage. Now, these are the industry standards, before we sell out our ESD device to any customer and all, it has to pass some industry standard. So one basic industry standard, or like the commonly used standard used by the companies very much often, is actually the human body model. Means if I am touching the IC, then it needs to be modeled in terms of human body model. Now, typical capacitance of the human body is around 100 picofarad, whereas the finger resistance is around 1.5 kilo. So this is the industry standard people use for the industry devices and the industry circuits. There is another way is actually to model is actually machine model. Now, let's say if you just talk about the semiconductor industries, there is nothing is actually human. Human are just for the watching and then just for the observation. Everything is done by the robotics. Okay, so when the robot is actually get charged, and if it touch your IC or the chip, to model such behavior, we have actually this machine model. So it has some capacitance, it has some inductance and all, and you actually charge your device with this particular scenario, and then you measure the voltage across the device under test, that how much the things are coming. Now there is one more model which is actually used by the industry, is actually the charge device model. Means, let's say if two chips are getting connection to each other, means unwantedly the one chip actually transfers some voltage to the another chip. So these three industry standard model actually used by the industries very oftenly. And like if you have in your basic electronic course, you might have seen the diode spec sheets and all. So it has a certain voltage range and all. So when industries actually ship out these ESD devices, they also put the rating out that what kind of a human body model they have charged. So typically we use the 2 kilovolt, 1 kilovolt. I will tell you that now forward they are actually going to use the 0.5 kilovolt, because of the technology is actually evolving. And these are the, I haven't shown that what are the current magnitude I have been talking here, but these are the typical response when you test these models, industry standard model. This is what the typical characteristic look for the HBM, CDM and MM model. Okay. Now let's come to the, because we are talking here is that technology involvement. Okay. So there are, as I was saying, there is your operating region below which your chip is working. There is a breakdown region where you really don't want to your chip should work, and in between you have a ESD design window. Now, as I was saying that as the technology is evolving, your ESD design window is actually very much shrinking. Now the consequence of this is actually, so typically in past, like in 1970 and 1998, people were using 2 kilovolt human body model. But when the technology is shrinking and your ESD design window is shrinking, your margin is also shrinking. So the same device which was actually able to handle the 2 kilovolt human body model kind of thing, now it is not able to handle 0.5 kilovolt also. So this is what the prediction that if we really want to go for the upcoming technology, you should have to pass the 0.5 kilovolt human body model test also. So that is the projection. Now these are the things actually one of my BTech students has done in terms of benchmarking, that what are the solutions are available. Like as I was saying that we are going to use the 1 volt device and 2 volt devices. So these are the benchmarking we did, and we found certain gaps that certainly, like when we actually want to trigger and when we want to talk about the low voltage devices and all, you actually want to have additional circuits to reduce the ESD design margin and all. Along with that, they are not that much area inefficient and all. Okay, so moving forward, I'll just briefly go about that what are the research opportunities in terms of the ESD. So if you actually talk about that in terms of the technology scaling. So when we are actually moving forward from one technology node to another technology node, the material, the device architecture are changing. But at the same time, there are certain challenges with the ESD. For example, when we talk about the gate length of the MOSFET, which is actually 10 nanometer or 14 nanometer, your channel heating. So the heating which is generating because of the movement of the carriers is actually getting higher. So your ESD trigger voltage is also changing. Okay. Now coming to the, in terms of device architecture innovation, so this is what we are predicting, that the new chip what we are going to get from the Samsung, which is at the 3 nanometer technology node, and that is supposed to be come in our upcoming phones and all, is going to use some kind of a vertical devices. Okay. Now as of now, nobody have kind of predicted and nobody has studied that what kind of a ESD will be, what kind of a behavior of these devices. So this is also one of the area where people want to focus and people want to understand that how the ESD going to be and how we are going to tackle down the ESD kind of things for these newer upcoming devices. Now, in terms of the device architecture and the materials, so there are several new devices are coming, which are the industry standard devices. So one of the industry standard devices is actually silicon on insulator, mainly preferred for the analog application and for the radio frequency application. But the problem with this device is that because of it has some insulator in between your active area and the substrate, it actually has a heating problem. The next thing is the graphene, which is also a kind of considered as a new material in the electronic industry. It's very thin, having a thickness of 0.5 nanometer and 1 nanometer. But as I was saying that ESD devices are actually work in the very high current density. So if you have a very thin device, so the current handling capability is going to be a big question. So people are also investigating doing some research on that, how we can design a graphene-based ESD device or the circuits. This is the newest area, and this is actually like we are actually have kind of rolled out last year, I think so, 5G spectrum. Okay, and what now government is actually focusing on the 6G spectrum and all. So US has started the 5G. Okay, now India is also slowly starting the 5G, and then people are actually working on the 6G, sixth generation communication and all. Now when we actually talk about the sixth generation communication and all, we can't use the traditional devices. You need a devices which can a higher frequency, they can actually work in the gigahertz range and all. So gallium nitride is actually the industry standard device. Okay. We in IIT Kanpur actually are working in these devices. We are making the industry standard models, which are widely used by all the companies like Google, Apple, Qualcomm. If you take any company name who are actually working on the circuit designing and chip manufacturing, they're actually using our industry standard model, which we are designing in IIT Kanpur. So gallium nitride is actually one of the candidates which people are using. And there are several challenges also with these devices. So we are actually going to investigate in the future that how the gallium nitride is actually going to work as a ESD device. So with that, I would like to just summarize my talk that hopefully, I believe that the talk was super fast, but hopefully you might have get something out of this. If you really want to have some more discussion about these topics, I'm not just only working on the ESD, I'm also working on the neuromorphic computing, AI, ML. So, but most of the works with what we and my group actually is carried out more toward the industry related aspect. So you can always reach out to me through my email ID. You are always welcome to IIT Kanpur. If you have any interest in the research or you want to work on some industry specific problem, you are always welcome. Okay, thank you once again. And if you have any question, I'll be very happy to answer.
Thank you, sir. Yes, sir. Students, if you have any doubt, if you have any question, you may ask. Anyone? Okay. Thank you so much, sir.
Thank you, sir. We are truly grateful for your enlightening speech, and I am sure that it has left a profound impact on all of us. Now I would like to request all the esteemed dignitaries to kindly proceed for lunch plated at Boys Dining Hall. Sir, please.